Welcome to day 2 of the 6.5 Summit. It's our 5th year. After the AI build out in 2023 of a lot of infrastructure and tools, this year's summit is all about expanding the AI footprint into the data center, into the edge, and delivering real value across enterprises and consumers and customers. So semiconductors have really been the tip of the spear for the AI discussion. And Daniel and I have joked that semiconductors are eating the world versus software. That was the meme last decade. They really are. And whether it's compute, memory, networking, and storage, AI is pressing the limits of all these chips. And with that said, it is my distinct pleasure to introduce our semiconductor track opening speaker and friend of the 6.5, Jinman Han, president of Samsung Semiconductor. Welcome back to the 6.5.
Oh, thank you. Thank you, Pat, for having me. I'd like to start by saying that we have to remind ourselves that about 60 years ago, Roy Amara, from Stanford scientist, he said that, the impact of technology is overestimated in the short term, but underestimated in the long run. I think we really have to think about that. But whether we are now in era of overestimating AI, we're not so sure. But in the long run, I'm pretty sure this will be the start of AI era. Right.
Yeah, it is amazing how far it's come. And in fact, in the 1960s, the first AI algorithms were created. We didn't do much with it for about 30 to 40 years. And then through advances in semiconductor technology, programming expertise, and a whole other confluence, here we are in the world of generative AI. Can you talk about, from your point of view, as literally one of the largest semiconductor companies on the planet, how is generative AI redefining your space?
I don't really want to talk about the market situation because AI is one of the very few bright spots that we are seeing huge demand from the
Right.
market. But from the semiconductor point of view, I believe that this AI will redefine our manufacturing in addition to design processes in a whole different way. I believe this is a kind of virtual cycle because we are now providing semiconductors, both memory and logic, to the industry. But this will create new application or use cases for AI. But at the same time, this will help us re-optimize our design process and manufacturing process, which is working kind of a virtual cycle. So it's going to be very unpredictable what this interaction will bring in the future, but it's going to be pretty good and pretty exciting.
Yeah, it's interesting. As an industry analyst, I really have to work hard to call something a fad or a trend. And I'll typically go to the end user in the research that we do to determine that, and then go out through the entire value chain. And it's absolutely a trend. I mean, I met with some end users on the enterprise side that were seeing a 50% increase in efficiency in their creativity process. And we're seeing this in multiple verticals, in multiple spaces. And we haven't even touched the consumer side yet, a little bit, but on PCs and smartphones, we believe that the best is yet to come. So Samsung, as a foundry and a designer and IDM, you
Right.
have to make huge bets years in advance on what's going to what is going to be driving a
Mhm.
demand and where. And I'm curious, so you have to be very closely tuned in to industry trends. What are some of the industry trends that you see right now changing in the semiconductor market?
Okay, so one thing that we are noticing right now is that suddenly the demand for high-speed SSD is going up. It was not like this last year because last year everyone was talking about compute and the memory.
Right.
So everybody was wondering, what's happening with storage area. And suddenly, all this year, we are starting to see huge enterprise grade SSD demand going up, and this is all because of this high performance GPU and increased number of parameters for AI models. And also at the same time, you also have to make sure that your trained data has to be saved every hour. So you really need very fast SSD technologies. And this is really interesting. And right now we are seeing which one is making limitation on this whole system from end to
Yes.
end. So sometimes you see memory, sometimes GPU, CPU, and then storage. It's just fighting for each other. So that it cannot be a bottleneck for this whole systems. That's the thing I'm seeing right now. Yeah.
Yeah, I'm so glad you brought that up. And I like to call that the infrastructure quadrangle, right? And I said it
Right.
in the run up, which is every big inflection point we've seen really required a balanced approach to the compute, memory,
Mhm.
storage, and networking. And if one of those four is not in alignment, you probably won't get the results that
Exactly.
you want. And that's where, I mean, everything I've seen from, I mean, gosh, all the way to the smartphone, to the
Mhm.
AI PC, to what's going on inside of the data center, memory and storage it has become a bottleneck, and
Right.
therefore faster and more is going to be what's going to happen this year and beyond. So I think that should be very good for Samsung Semiconductor.
Yeah.
Um, yeah. So no, please go ahead.
Yeah. So, but behind all these technological requirements, we keep hearing from our customers about power reduction, power efficiency, because this powerful model requires more demand from GPU and even memory and storage, and this power issue is getting critical.
Oh yes.
Right now, I believe that in United States, about 4% of electricity consumption is caused by data center. 4% is not big number, but when you think about the concentration of data center in a very specific region, it's a huge demand for the region. So power efficient chip requirement is getting higher and higher. Although we know that more efficient chips will stimulate more demand, so people might
Right.
buy more chips, but eventually we're going to hit the wall. But at least it can allow us to have more function using the same power. So it's good for all of us. And you know what, Pat? This week is Earth Week, so we really have to think about this low power, green energy, you know, issues.
Yeah, I'm glad you brought that up. Sometimes, we throw around performance, capacity, and
Yeah,
we don't hit on, I mean, literally within a year, we're supposed to double the amount of power draw from data centers. And a lot of
right,
that has to do with accelerators. And that's real capex that people are looking at, and anything that can be done on the foundry side, the memory side, and even the storage side means that I like to call it power sloshing. You can provide that power savings either to the compute, the GPU, or the
right,
processor, or you can just reduce your overall footprint. And
right.
for all those who are listening out there, it is really hard to deliver high performance, increased capacity, and lower power all at the same time. But welcome to Jinman's world here. So no, it's a huge challenge.
Right. It's a huge challenge. We try to develop power efficient chips. That's everybody knows about that. That's for sure. But also, I believe that we also have to think about new process technologies, which can endure high temperature in the harsh workload environments. Otherwise we have to invest too much capex on cooling system. I know a lot of companies are working on next generation cooling system, liquid cooling, but the semiconductor is not conducive to heat. So we also have to think about how to develop new process so that our transistors can be more resistant to any heat uh, caused by this demanding workload. And also, we're gonna develop power efficient architecture so that we can reduce power consumption in the first place. So that two-track approach might be needed in the future from semiconductor industry, including Samsung.
Yeah, one of the key trends too is supply chain diversification. I'm curious what your thoughts are about. I mean, I'm here in Austin, Texas, and Taylor, Texas. You're making a multi tens of billions. I think the overall commitment was 100 billion. The recent commitment was 40 billion. So you are definitely one who's diversifying your manufacturing in multiple parts of the globe. Can you talk a little bit about that?
Oh yeah, we had a very nice ceremony last week acknowledging the CHIPS Act funding from U.S. government. It's the most expensive money I talked before, like, because U.S. taxpayers' money, right? We have to spend very wisely. And so our main goal is to have a big presence in the United States so that we can not only produce chips, but also we want to do R&D as well as advanced packaging. And eventually we really want to promote raising this workforce in semiconductor ecosystem. So that's a huge goal for us. But the last week was the first step. We got the funding from U.S. government. We really appreciate that. And uh, you said, we really have to also think about not only geopolitical diversification, but we also have to think about geographical diversification, right?
Right.
So all different things we didn't expect before is happening. It's like a black swan event, and we believe that Samsung has to be very resilient in terms of supply chain by having multiple locations as a provider for semiconductor, including Korea and US, of course. Um, Also, we really want to emphasize, not just big companies like Samsung, but we also have to think about collaboration between big players and small players like startups, so that we can,
Right.
commonly recognize value of this diversification, and especially for this data center AI solutions. I think there are a lot of things we can do together, not just as a supplier or customer, but as a ecosystem builder. I think in that, I believe Samsung can play a significant role in the United States.
There's one thing, digital twin technology. I'm curious if that's intersecting your world. I mean, the sophistication of your manufacturing, the design you have to do. I would expect
Mhm.
that you must be looking into this.
Oh yeah. So before, this digital simulation is really bread and butter for our development process, right? We have to simulate our chips, even though we don't have any process ready, and then we also have to simulate all the devices, how it's going to work when you process the chip. And right now, because of this great technological advancement, we believe we'll be able to simulate the whole chip, a whole fab. I mean, we can simulate the whole fab so we can see what's going to happen to the process, how we can optimize our all these equipment placement, or how many wafers can we produce by changing these processes.
Right.
It's going to be amazing, right? So even though we don't have any fab ready in the next 2 or 3 years, we might be building our fab in the virtual environment. We may be able to run the simulations to see what's going to happen. It's going to be amazing, right?
Yeah, it really is. I mean, the tools, particularly, I mean, for design, validation, are pretty amazing. And
Right.
interestingly enough, similar to other areas in terms of performance improvement, even on even creativity tools. Using Adobe Firefly and things like that, or some of the AI that Salesforce has. So it's super impressive. So with all of this new technology coming out, right? Some of the new popular things are chiplets,
Mhm.
which is revolutionizing allowing smaller companies to innovate and
Right.
be brought to market in a big company foundry, custom HBM, advanced packaging. These all have the ability to speed up the innovation process. And I'm curious, how are you pulling elements like that together to increase time to market and enhance innovation?
Yes, Pat. That's one of the reasons why our customers are so excited about Samsung's so-called one-stop solution, because we have memory, logic process, foundry business, as well as advanced packaging. So we believe we can combine all these technologies in a much more chemical way, so that we can provide holistic solution to our customers specific to their needs. Right? I think there are not many companies in the world can provide that solution. Yeah, and then this chiplet approach is very flexible. It's kind of a mix and match approach, like a Lego block. But I think it just started. I think it's just tip of the iceberg. What I'm thinking in the future is that we're gonna explore more dimensions to add. We are not talking about 2.5D, 3D, but it's all between memories and logics, small chimneys. But when you really think about it harder, there are a lot of areas that we can add more dimensions. Maybe we can add uh, IP chiplets. Maybe we can have 3D interconnections, right? So there are a lot of room for us to grow into in the future. So this is just the starting, and I believe there are a lot of players in this ecosystem, but Samsung is in unique position to provide very specific, tailored, a bespoke approach to each individual customers. Yes.
Yeah, and I really like that you're an IDM and you're also a foundry as well, right? So you have experience on what the end product would look like. And if AI has shown us anything, it's that a very tighter connections
Mhm.
between the compute, other types of IP,
Right,
high bandwidth memory, and then all of the solution put together in advanced packaging is really a requirement, right? That,
right.
with Moore's law slowing down, we had to find ways to deliver the end performance that
Exactly.
we needed. It's so funny. When I worked for a semiconductor manufacturer years ago, packaging was kind of a sidelight, and now like it's a first order citizen along there with the
Right,
design. I think that's super exciting and also an opportunity for Samsung Semiconductor.
right. We are very excited to have this advanced packaging business unit. We just created a team last year, and then it's getting bigger and bigger. But there are lots of different requirements from our customers. So I think our engineers should work harder to meet all those demands. But it's a area that can lift us out of this end of the Moore's law wall. So I think we'll see a lot of great breakthroughs in this area.
Yeah, I'm super excited on all this. I mean, chiplets to me, I mean, I'd love to see small companies who get paired up with foundries like Samsung Semiconductor capability where they can have a design, have it qualified and ready for the final product to be brought together. And by the way, these new packages blow my mind because typically packages added power and it decreased performance in connecting chips. And now we have chips. We actually have an architecture with chiplets
Mm.
that through packaging, we keep the performance and we keep the power low. So yeah, packaging is like this first order citizen. So
Right.
we've talked a lot about your thoughts on the industry today, kind of how we got here with AI, some of the unique parts that Samsung Semiconductor brings to the table. But let's talk about the future. What types of technology and markets do you see driving the future? I mean, you have to make $50 billion commitments up front and beyond before you even know what the market is, 3 to 4 years in advance of the market even being there. It still blows my mind, even
Yeah.
even though I worked for a semiconductor company for over a decade.
Pat, I do predictions a lot, as other people do. But problem is accuracy, and you know, even 2 years ago, we didn't expect this OpenAI chatbot thing to,
Right.
be like this. But in 3 years, we may see great things. I heard that there are lots of, disruptive AI models being developed at the lab. I don't know what that really are, but I'm very exciting excited to see what those models will be. And so in semiconductor, it's fairly comfortable for us to predict 1 or 2 quarters ahead because you have to put your wafer in the fab, so you know what's going to happen. But after 2 quarters, it's very hard to predict. But we believe that in the future, this quantum computing might be one of the areas that
Yeah.
will give us huge growth, as well as healthcare as use cases. That's for sure. I think everybody's agreed upon on that. But I'm also thinking about these robot technologies, right? Pat, you know what? In South Korea, every child women give birth to is about zero point 0.6 or zero point 0.7. We
Right.
need 2.1 to maintain our population. I don't think this is unique to South Korea.
It's not.
I think except for some continents like Africa, the population is not growing as fast as before. So we really need to compensate for that, like automotive, self-driving car. They are all robots, and with this great VR, AR technology and robots and this AI, these are all dots. When you connect all together, we may see great way of compensating for this population, decrease. Also, at the same time, this will allow us to have higher productivity, right, to make this economy going forward. So I don't know what's going to happen within the next 3 or 4 years, but it's going to be really great
Yeah, it
technology.
really is. And I'm convinced too that, with all the action that we're seeing in the data center, and my firm has been calling the start of a PC super cycle starting in the middle of this year and really ramping in the first half of 25. I also believe that if we do what we need to do on the smartphone side and with on-device AI, with, by the way, more memory, more storage, more NPU compute, we're going to be driving a lot of cool use cases to drive that. And one thing we haven't talked about yet that I'm excited about is, and you hit it with robotics, is generative AI in the industrial IoT. I think what we found is that if you process data on the edge, let's say it's smart factories, smart
Right.
transportation, it makes the investment of replacing what's on the edge a lot more meaningful because it basically pays for itself. And I know people aren't talking a lot about that now, but watch this space as AI goes from the data center to PC to
Right.
smartphones and then to the industrial IT and
Right.
like places like you said in robotics.
Right, exactly. And behind all of this great technological advancement, we need semiconductor.
Oh, I mean, it starts everything.
Yeah.
There are people that said software is eating the world, and I always like to say, yeah, but software can't run on air. And Jinman, the last 40 years of technological information, um, semiconductors and hardware has leaped over each other. Right? It's been this virtual cycle, which has
Right.
been the hardware and the semiconductors do this big build out. The
Mhm.
developers have a lot more to work with. They drive a ton of software development, and then they're like, I need more, right? So
Right.
it's
Exactly.
fun to see the overlap here, and Samsung is taking a huge role in driving this generation of generative AI. So want to thank you for coming on, Jinman. I really appreciate that.
Thank you for having me. Always a pleasure.
Yeah, absolutely. And so you heard it here, the kickoff for the 6.5 Summit 2024 Semiconductor Track. Appreciate you tuning in today. And hopefully you see the value of memory and storage in the quadrangle of AI, and how Foundry and Foundry services make this all happen. And essentially, delivering the AI economy, because without these semiconductors, it's not going to happen. So stay tuned for all the day 2 coverage today, and make sure you check out day 1 because, it's on simulcast. And of course, check in for day 3. Thanks for checking in. Appreciate that.